Hey guys, welcome to Worms Maths Academy. I don't know how much I'm going to get through tonight. I might just do the multiple choice. My brain's a bit fried from doing 50 million questions with students these last couple of weeks. So, let's have a look. I haven't spoken to many students. When like after this exam, I've just heard a few say that it was still really hard, and the feedback mainly was that it's really long. So I think everyone is pretty much in the same boat. So all I can say is don't stress too much, because it all comes out in the wash. It's all relative. So don't stress yourself out. If you think you did shit, you may not have. Everyone else has done shit, so it's all relative. The kids who are going to get 30 study scores are still going to get 30 study scores. And if you are lucky, you might have answered a few questions more than other people, and your mark might go up. Okay, so let's have a look at these questions. We've got two functions, their x values and their y values. We want to find g of f of 1. We know f of 1 is 4. So we want g of 4, which is 6. Nice easy one to start. Okay, a polynomial, a is a real number, p is divided by x plus 2. The remainder is 5. So we know p of negative 2 is equal to 5. Negative 8 minus 8a minus 2 minus 1 is equal to 5. Negative 8, negative 10, negative 5, negative 16 is equal to 8a. A is equal to negative 2. I've got a derivative and I want to anti-diff it. And I know when x is 6, y is 4. So desolve y dash is equal to, I need a paper copy next to me, 2, I think it was on 2x minus 3 x y. I think y of 4 was equal to 6, or y of 6 is equal to 4, one or the other. Y of 6 is equal to 4, is that what I just wrote? Other way around. Okay, 2 root 2x minus 3 minus 2, 2 root c. Okay, here we want to solve this function. Let's just do it on the cas. So 2 cos x minus, I think it was pi on 3, 2x minus pi on 3, pi divided by 3, I think it was minus 1 equals 0. If it's not, I can always change it. Plus 1, of course it wasn't the right one. Okay, so k pi minus pi on 6 and k pi plus pi on 2. Okay, they're all over 6's, so let's make this a 6 and a 6, make this a 6 and a 6, make this a 6 and this is a 3. Pi on 6, 6k minus 1. Pi on 6, 6k plus 3. D. Okay, 3x plus 2 on 5 minus x. We want to find the maximal domain. Oh, okay, and we want to find the asymptotes. So 3x plus 2 on 5 minus x. 3x plus 2, 5 minus x. Prop frac. X is 5, y is negative 3. Okay, this is a derivative graph. So this is the positive, 0, negative, 0, positive. Positive, 0, negative. We need to have x in turning points to the left of the asymptote, so it's not that. Positive, that's a turning point, positive gradient, positive gradient, and then it remains positive. I'm tipping it's this. Turning points are not to the left, so it's got to be B. Okay, I've got an exponential and I want to derive it, e to the g of x squared. We know when we derive e to the f of x, it's f dash of x, e to the x. So we want the derivative of this, e to the f of x, I should say. So let's let y equal g of x squared. U is the inner function. We want g of u. Y is g of u. U dash is 2x. Y dash is g dash of u. If we multiply them, we get 2x g dash of x squared. So we know that's our derivative. So it's got to be one of these. And then we multiply it. We know it's not that one. It's this one. We multiply it by e to the function. Okay. Items are packed in boxes of 25, and the mean number of defective items per box is 1.4. So we know n is 25, mu is n times p, that's 1.4. So we know p is equal to 1.4 on 25, which is 7 on 125. And we want to find binomial, the probability that x is more than 3. So we've got 7 on 125. What's that? Discrete. My lower is 4 because it's more than. My upper is 25. I've got 25 trials, and my chance of success is 7 on 125. 0.0484 B. Okay, we've got from 4 to 8 of f of x dx is 5. This function here is dilated 1/2 from y, and then 2 units left, which means if we dilated 1/2 from y, we would get 4 and 2 as our terminals, and our area would halve. And then if we translate it 2 units left, we would get 2 and 0 as our terminals. However, the area wouldn't change, it's just translated left. So our area is going to be 5 on 2. Okay, log 2 of n plus 1 is equal to x, the values of n for which x is a positive integer. So we've got to have log 2 of 2, log 2 of 4. So it's got to be log 2 of 2 to the something. In this case, it's k. And they tell us k is a positive integer. So it doesn't matter what k is, as long as it's an integer. This is going to be, if k is 1, this is going to equal 1. If k is 2, it's going to equal 2. If k is 3, it's going to equal 3. But we've got that plus 1. We're going to have log 2 of 2 to the k minus 1 plus 1. So they cancel out. We need to get rid of the 1. So we've got to put 2 to the k minus 1, and the plus 1 will cancel each other out. Okay, the lengths of plastic pipes that are cut by a particular machine are normally distributed random variable x with a mean of 250. Z is a standard normal random variable. The probability that x is less than 259. So that is equal to the probability that z, 1 minus z, is greater than 1.5. So z is less than 1.5. We want to find the standard deviation. So we know our mean is 250. X is 259. We know our z value is 1.5. So z, 1.5, is equal to x, which is 259, minus mu on sigma. We solve for x, we get x is 6. Okay, a clock has a minute hand that's 10 centimeters long and a clock face with a 15 centimeter radius. So if it was up there, it'd go 10 and 10, so that distance is 5, and that's 25. Okay, so the height is to the tip of this thing. 12 noon, both hands point vertically upwards. And the tip of the minute hand is at its maximum distance above the base of the face clock. The height of the tip of the minute hand above the base clock. So it's starting at its maximum, which would be 15 plus 10, and it's got to be a cos graph. Scrap those. They're both the same. The period has to be 60. So 2 pi on n has to equal 60. N has to equal pi on 30. So it's E. Okay. Here, we're going from cos to 2x plus 4. So we could either go f of x plus 4, which would become cos of x plus 4, and then f of 2x, which would be cos of 2x plus 4. So if we translate it left 4 and half from y, the translation first, left 4 and a half from y, that works. The other way we could do it is if we did cos 2x plus 2, so then we would dilate it a half from y and then 2 left. So there's a half from y, but it's not 2 left. And that's not a half from y. It can't be that because that's the translation first because it's in a bracket. So our answer's A. Okay. The random variable x is normally distributed. The mean of x is twice the standard deviation of x. So let's say the standard deviation is x. The mean would be 2x. The probability that x is greater than 5.2 is 0.9. So there's 0.9. That's 5.2. So we know this area in here is 0.1. So we can say, let's find that z value for 0.1. negative 1.281551. And we know that's equal to x, which is 5.2 minus mu on sigma. So we say that is equal to x, which is 5.2, minus mu, which is 2x, on sigma, which is x. (7.238). Okay, part of the graph of the function where a is greater than 0. So we know that area and that area would cancel each other out. That area and that area would cancel each other out. So all we're left with, that area can add to that area and we get 4 boxes. But we've got to do it over that interval. So we know we've got to have 4 boxes full. So we know it's going to be about there. If that's A, that would be A on 2, so it's got to be a bit less than A on 2. It's got to be A on 3. Because if you have 6, a width of 6, if you have 4 divided by 6, you would have 2/3 of 1 box. That doesn't make sense, but that's definitely A on 3. Okay, right angled triangle ABC, horizontal axis m, 9 minus m squared between 0 and 3 on the parabola. On the parabola. Oh, okay. So we know that's m, and that's 9 minus m squared. The area is a half m 9 minus m squared. So a half x 9 minus x squared. We want to find the maximum, not the minimum, between 0 and 3. 3 root 3 when x equals root 3. Okay, a turn to the graph of f has a vertical axis intercept at 0, c. So that graph would have an asymptote at -2, and it's been reflected in the x-axis. The maximum value of c, which is the y-intercept of the tangent. So if we drew a tangent here, that's going to be low, low, low. When we get to there, it's going to go through the y-axis, and when we keep moving, it's only going to get lower. So the maximum tangent, because they're all going to go downwards, and they're all going to go back there, is going to occur at the y-intercept of the graph. If you let x equal 0, you get y is negative log e2, which is c. Okay, a is an element of 0 to infinity, so a is a positive number. This graph has an asymptote at y equals b, and also 1 at 0. The graph is defined from -a to 0 and from 0 to a. So we know the range is -infinity to that value and that value to infinity, so it's got to be one of these two. If I sub -a into this, we get a on negative a plus b, negative 1 plus b. So that value there is inclusive. So it's got to be d. If I put a into here, we get a over a, which is 1 plus b, which gives us that value. So it's 1 plus b to infinity. Okay, shown below is the graph of p, which is the probability function for the number of times x that a 6 is rolled on a fair-sided dice in 20 rolls. So p is 20cx, success, which is a 6 to the power of x, failure to the power of 20 minus x. Q is the probability functions for number of times of w that a 6 is not rolled. Q of w is 20cw not rolled to the power of w rolled to the power of 20 minus w. They look very similar. Let Q be the probability function with the number of times w that a 6 is not rolled for a 6-sided dice. Q of w is given by... Okay, so if we replaced that and that, if I made that 20 minus w, you can see that they'd be exactly the same. If I made this x 20 minus w, I'd get 20 minus w, which would be w, so that would be the same. And then here, 20cw is equal to 20c 20 minus w. Because of the symmetry, we know 20c1 is equal to 20c19. So it's w minus 20. If I replace that with a w minus 20, it's the same as that. If I replace that with a w minus 20 minus w, it's going to be that. And those, because of symmetry, they are the same thing. Okay, last question. Cos of ax, where a is any real number, has a property with the function f of x is f of x plus h. So what that means, it's a cos graph, and we know each h it repeats, but h has to be, the period has to be an integer. So the period could be 1, the period could be 2, the period could be 3, but it has to be an integer. Now we know, let g be a function where we're using this periodic function and it has a range of -1 to 0. So if I say log 2 of f of x is equal to -1, f of x is equal to 2 to the -1, which is a half, and log 2 of f of x is equal to 0, f of x is 2 to the 0, which is 1. So my range of this graph has to be between 0, between a half and 1. So it's got to be between there and there, or there and there, or there and there, or there and there and there. Okay, so if you think about it, our cos graph here, if cos x equals a half, x equals pi on 3. So that distance is pi on 3, that distance is pi on 3, that distance is pi on 3. out of a full period of a graph, pi on 3 out of 2 pi, pi on 3 divided by 2 pi is pi on 3 times 1 on 2 pi, which is 1/6. So that's 1/6 of a full graph. And if they're integer values, the smallest integer that we could have would be the period is 1. So if the period was 1, it would be 1/6, because it could be that section there, that section there, that section there. So here I've got 3 on 12 and 5 on 12, which is 1/6. That there is 1/6. That's 1/3, so we know it's not that, because that would be that whole section. Could it be that whole section? Because that, if we went from here to here, that would create a range from, because if I went from there to there, that's 1/3 of a full graph. That's also a third. If the domain, like if the period was 1, we know if it was a third, that value there would be, that's 6/6, so this would be 5 on 6 up until 7 on 6. So it can't be that. Negative 1/3, it can't be that. Negative 1/12 to a quarter, can't be that. It's got to be one of these two. If that was 1, we know the quarter would be there. So the range is going to be too big. It can't be that. It's got to be B. That's the only possible answer. Because if we go from 1 to 7 on 6, that's 1/6 of a full graph. And that's the only way that we can get a range of a half of, we can get values that give us a range of this function being from 1/2, positive a half, up until 1, a half to 1. If you have values from a half to 1 in this, it'll give you a range of -1 to 0. So 20 is B, but that's bloody confusing. So we know the period of the graph has to be an integer, which means that A would have to be 2 pi something x, because it would be 2 pi on 2 pi. That would give you an integer value. I don't know if I've made any sense there, but it's going to be B. Hope you guys went okay. Don't know about the hardness of this. Couple of hard questions. Overall, I thought it was reasonable though. So I thought the multiple choice isn't too bad. I think maybe I'm thinking it's easier than what it is. Maybe it was super hard, I don't know. Best of luck to any special kids doing special tomorrow, and I'll put up the part 2 as soon as I can. Bye.